Welcome to Maths and Science by IITian. In this lecture, I will be taking up a typical example of a logarithmic number to the base of a complex number. Base is complex number. You might have heard about log 10 to the base 10, log 10 to the base 2, log 10 to the base 3. If the base is a complex number, what happens? Log 10 to the base 1 plus I. What will be its value? How it is to be solved? It's a very good example on the applications of logarithms, and it's a very typical and it is not a frequent example. It's not a frequent example. It's a very good example. I will be discussing here logarithm with a complex base. Log of a number with complex base. Here log 10 to the base 1 plus I. 1 plus I is a complex number base. 10 is a real number. In the next lecture, we will be discussing with log of a complex number with base as a complex number. What happens? In this lecture, I have taken log of a real number with base as a complex number. What will be its value? It's not log 10 to the base e, it's not log 10 to the base 10. It is log 10 to the base 1 plus I, which is a complex number. It's a very typical question. Let us try to solve it. For explaining the system, it may take a little more time for me, but however, once the concepts are understood by you, you will be able to solve this type of problems in the examinations very easily. This will be very useful for JEE, Maths Olympiad and CSIR. Or you can say IIT JEE. It's a very typical example. Let us try to solve it. What is the question given here? Question is to find logarithm of 10 to the base 1 plus I. Base is 1 plus I. What is its value? Will this value be given in? Is the answer going to be a complex number or a real number? We are not aware. Let us try to solve it. What is the solution? Step by step, please try to understand. Log of any complex number to the base a is equal to log of that complex number divided by log a. This is the definition. Please remember. Here, real number is a subset of complex number. You please remember. Log z doesn't mean that log z should have all the complex coefficients also. It can have 0 as the coefficient of I. Z is equal to complex number a plus ib. It can be a plus ib, a minus ib. B can be either negative value or positive real value. This is the form of the Z. A number. And if b is equal to 0, then z represents a real value. If b is not equal to 0, then it represents a complex number. A and b if they are present. If a is equal to 0, then z represents a purely imaginary number. These things I have already explained in previous classes. Then from this definition, log 10 to the base 1 plus I is equal to log 10 by log 1 plus I. When you take natural logarithms, ln 10 by ln 1 plus I. This is from this formula. Now, what is the question given here? Log 10 to the base 1 plus I can be written as ln 10 by ln 1 plus I. I have already in my previous lectures, I have already told you many times to remember the ln values up to 10. That will be convenient for you. ln 10 is nothing but ln 2 into 5. ln 2 into ln 5, 2 into 5. That is, it is not into here, it will be plus. ln 2 into 5 whole divided by ln 1 plus I. That is equal to ln 2 plus ln 5 whole divided by ln 1 plus I in simple terms. That means log 10 to the base 1 plus I is equal to ln 2 plus ln 5 whole divided by ln 1 plus I. What is ln I plus ln 2 plus ln 5? It is approximately 2.30. These values please try to remember. ln 2 is 0.693, ln 5 is 1.609. These values I have already given in my previous lectures. Please see my previous lectures on logarithms and exponents. Whole divided by ln 1 plus I. The challenge here is to find out what is ln 1 plus I to the base e. What is ln 1 plus I to the base e? 1 plus I is in the form, we can say it is z. That is equal to a plus ib. Do you agree? Where a is 1 and b is 1. This formula also please remember, ln of a complex number, natural logarithm of a complex number is equal to ln magnitude of z. Ln z is equal to ln magnitude of z plus I into argument of z. Argument is nothing but angle in radians. We will take the principal value only here. We will solve it for principal value of the angle. You can go for the other values as a homework. Ln z is equal to ln the magnitude of z plus I into argument z. This is one of the most important formula you should remember, logarithm of a complex number. Here we are talking about the logarithm of a complex number to the base e. With this we are going to find out logarithm of 10 to the base complex number. Now, what is ln 1 plus I? ln 1 plus I is equal to ln magnitude of 1 plus I plus I into argument of 1 plus I. Do you agree? What is the magnitude of 1 plus I? This is nothing but square root of 1 square plus 1 square, which I have explained in my previous lectures on complex numbers. Magnitude of a plus ib will be square root of a square plus b square. Here a is 1, b is 1, hence 1 square plus 1 square square root of 2. We will find out the argument, principal argument in the first quadrant only. I am not going to solve for other values, that you will do as a homework. Mathematics can be understood when you do on your own. I will do it for first quadrant. Other quadrant values, if they exist, please do it. That means what is the value I am taking? Argument 0 to pi by 2. My argument value is pi by 2. That is first quadrant. For other values, please do it on your own. I will give it as a homework at the end. How to? I will explain the procedure. Now, in the first quadrant, argument will be, what is the argument? Theta of 1 plus I. That will be, in general, argument of a plus ib is equal to tan inverse what is its value? Please tell me. Tan inverse b by a. This you please remember. This is a very important. These things I have already explained in my previous classes. Please see them. Please see those lectures on complex numbers. Argument 1 plus I will be tan inverse 1 by 1. That is tan inverse 1. That is equal to pi by 4. What is the value of tan inverse 1? That is pi by 4. That means, what is the value of ln 1 plus I? Ln 1 plus I is equal to ln magnitude of 1 plus I is square root of 2 plus I into pi by 4. What is the square root of 2 can be written as ln 2 to the power of half plus I into pi by 4. This can be written as half ln 2 plus I into pi by 4. Do you agree? This value? Then, what we have to find out? Ultimately, log 10 to the base 1 plus I. Therefore, log 10 to the base 1 plus I is equal to log 10 or ln 10 we can write ln 10 to the base e divided by ln 1 plus I. This ln 10 is 2.302 whole divided by ln 1 plus I is half into ln 2 plus I into pi by 4. Do you agree? Now, if you want to simplify it, simplify it. Otherwise, your answer can be this way only. I will give the homework here. Simplify and check if log 10 to the base 1 plus I is equal to half ln to half ln to is 0.693 divided by 2, I into pi by 4, that value also you can find out. In total, either you can put the value same as shown here, or you can simplify. When simplified, log 10 to the base 1 plus I gives the value 1.083 minus 2.453 into I. This is the answer. Then you simplify this. Now, homework is, this is when you have taken the principal values. Theta changes, argument changes for ln 1 plus I, keeping that formula intact. For different arguments, you try to find out solutions. And this is one of the solutions for taking principal values. We got this. For different values, keeping the equation intact, for different values of theta, keeping the equation intact, how to find them, the different solutions, please refer to my previous lectures. There are many lectures on complex numbers, because theta gets repeated. Every 2 pi the theta gets repeated. Please try to find them. When the principal values are taken, log 10 to the base 1 plus I is equal to 2.302, that is log 10 to the base e divided by half ln 2 plus I into pi by 4. When you simplify, the value will be 1.083 minus 2.453 into I. This is the value. That means here what we have done, we have shown that we need not have only real numbers as the basis. There can be questions with log of something with complex base. Log of a complex number with a complex base. That will be our next lecture. To find log of a plus ib with the base c plus id. This is our next lecture. I think to invent these type of things and finding them, solving them, requires in-depth knowledge of the logarithms, and whatever I do in my lectures is to invent the problems, develop the concepts even for the typical problems, and keep it in front of you. Please try to understand the concepts and do better in your examinations. Best of luck to everybody. If there is a value addition because of this lecture to you, please share and subscribe to my channel Maths and Science by IITian. This type of questions I will be finding with innovation, and I will be giving more and more this type of problems to you. I have already released about more than 120 lectures on mathematics for Olympiad and IIT JEE, Maths Olympiad and IIT JEE. Please see them. understand the concepts and do better in the examination. Best of luck to everybody. Thank you for seeing my lecture. Thank you for viewing my video. Thank you.